After spending most of Wednesday on the road getting lumber, Thursday morning I started the build by laying out the cuts for all 3 top panels. When laying out your rough cuts, it's important to take into consideration the checking or the cracking on the end of each rough sawn board. Sometimes you won't see checking until after you've cut some material away. And one thing I like to do is cut a 1/4 inch or a 1/2 inch off the end and look at the freshly exposed end grain of the offcut. Sometimes I'll find cracking inside the area of this offcut and not on the perimeter, which means you can't see it on the surface. I'll keep cutting small pieces off until all of the checking has been removed, and then that point is considered the start of the board, and I can make the rest of my rough cuts. If the boards have a lot of defects in them, I'll do this step before making any layout plans. Next up is the jointer for only 1 wide face and no narrow faces, followed by planing the pieces to final thickness. And with all the pieces in this build, I was trying to achieve maximum thickness and not necessarily shooting for any specific dimension. Back to the jointer for one of the narrow faces. The reason for the back and forth here is because if you try to joint the narrow face immediately after just 1 wide face, then you only have 1 option for the direction of jointing. Sometimes that can be against the grain, which will cause some bad tear out. You will have the option of going in either direction if you have both wide faces flat and parallel first. The board width is established next at the table saw, making sure to have the panel glue up 1 inch wider than necessary. Now this will allow a little bit of extra material to be removed later to clean up any tear out when routing the profile, and I'll talk about that in just a bit. The rest of the panel process is pretty straightforward. A carpenter's triangle on each panel for reference, loose tenons or biscuits for alignment and keeping the panels flat in clamps, glue, then squeeze them together making sure they remain flat. With the top panels and clamps, we started the milling process for the rails, and here's where I had the first thought of wasted time and a much more efficient process. We should have milled these pieces when we were milling the top panel pieces, but because of my normal no-rush shop time that I'm so used to, I typically don't mill all of my pieces at the same time. I am much more likely to mill only the pieces that I would use that day and try not to get too far ahead of myself in the event that I get distracted and have to leave the shop for, life stuff, right? That's not the case here. For the first time in a while, I have a strict deadline, and I should have milled everything at the same time. All right, time for the CNC to show what it can do. Because the smaller slots are 3/8 of an inch in width, I went with a 3/8 of an inch spiral upcut bit for all of the following cuts. First up are the long rails, and in this case, there are only 2 rails, so my standard left and right mounting locations on the horizontal table were used. The circle dogs, they're used just to locate and position each piece onto the table, and then they're removed after clamping. We removed them because 3 sides of the rail profile were being cut at once. This single program cut the interior slots as well as the left, right, and bottom edges of the rails. Cutting the piece to length at the miter saw or crosscut sled could have been done, but it's much faster in this case to surface 3 sides of the board and then program the CNC to cut the rest all at once. This is faster and ensures accurate dimensions with just 1 setup. No tabs were used in this setup as it would just slow things down, and I wasn't worried about the small offcut pieces going anywhere. Cutting the smaller rails left a lot of room for improvement, especially now that I can review the footage and kind of reflect on what was actually being done. It's the same setup as the long rails, but in a smaller space. There's also 10 of these pieces compared to 2 of the longer pieces, so technically all 10 of these pieces could have been mounted to the table at one time and then cut at once. If the room allowed, that's what I should have done. But a more simple change to increase productivity would have been to space these along the Y direction and not the X direction. I had every intention to remove the cut part and load the next board while the machine was running and cutting the second piece. But what I failed to take into consideration, or what I forgot about, was the gantry being right in the way as it traveled along the Y direction of the cut. So that means we could only load, cut, and wait. Had I mounted them along the Y direction of the machine, I could have had the machine constantly running as we would be constantly reloading the other location. At the end of this process, we had all of the rails sized, shaped, and ready for joinery. Next up is round 3 of milling, this time taking the 8/4 stock for the legs. And again, while this is my normal building process, I should have done all of the milling process in one stage. I simply underestimated how much using the CNC would speed up the process and how much more time I would have available. Unlike milling the rails, the final step to milling the legs was to use a crosscut sled at the table saw for cutting the legs to their final length. Now I chose to do this step before going to the CNC machine because of the shape of the legs compared to the shape of the rails. The rails were more flat, wide, making them easy to clamp down to the table. The legs are a little bit more narrow and a little bit thicker, which requires a little bit better clamping situation to make sure that they don't move on the table. It's actually easier to hold a pair of legs on the horizontal table than it is to hold just one. So that's what we did. 2 pairs of legs were loaded onto the table for each cut. And again, I could have loaded all 12 legs at once and cut them with a single program. But in this case, my limitation was actually the T-bolts for the hold downs. I have a bunch of bolts, but I don't have enough that are long enough for holding thicker stock. So the lesson with this particular step here is not only to mount more pieces to the table at once, but also to be better prepared with enough hardware to max out the capacity of the machine. For the rest of the cuts, I switched to a 1/2" 2-flute spiral upcut bit, and this is my go-to bit for the majority of all hardwood cuts on this machine if the diameter allows. The 1/2" bit, it's much stronger and it does not deflect like a 1/4" bit will, and it can just chew through wood with a much faster removal rate than a 1/4" bit. When cutting the leg mortises, we noticed a piece slipping, and it was basically because one of the clamps just wasn't tight enough. It was a dumb user error, but that's okay, because it's always best to cut at least one extra leg or one extra rail when cutting the parts for this very reason. Accidents happen, and if your material allows for it, you won't really be slowed down by cutting one extra part. So after noticing the problem, we made sure all the clamps were tight and cut both adjacent mortises on all of the legs. The leg tapers were kind of a hot topic for this design on Instagram. Not only straight leg tapers versus curved leg tapers, but also what machine to complete the task. What machine is actually faster? If this were a straight taper, I think I would have been faster by using a tapering jig at, say, the bandsaw or the table saw, and clean up the tool marks with a swipe of a smoothing plane. Super simple, super fast. In this case, I decided to go with the curved taper on both interior faces, and when it comes to a bunch of curves, it's nearly impossible to beat the CNC machine in speed, accuracy, and repeatability. So for this step, the machine really shined. I think this is the single step that saved the most amount of time on this build. And we could have made it a little bit faster by once again grouping our pairs along the Y direction and not the X. We could have taken that a step further by once again mounting all 6 pairs to the machine at once. With the mortises cut on the legs, it's time for the tenons on the rails. And one of my main reasons for pursuing this particular CNC machine was its open frame concept. You can make just about anything you want for it and mount it just about anywhere you want. I made a vertical table which allows for the joinery to be cut on the end of pieces. And just like with the horizontal table, the dog holes in the vertical table allow for repeat positioning as their exact location is calibrated and stored in my machine file on the computer. This makes batching out tenons, dovetails, dowels, anything similar to that to be very quick and easy. The tenon cuts are broken into 3 tool paths, and there's room for improvement in each one. First, a shoulder scoring cut is made, and this is a climb cut all the way around the board to ensure that there is absolutely 0 tear out on the shoulder of the tenon. An improvement here would be to make this tool path a full depth cut. A single pass full depth cut. Because the amount of material being removed, it's less than 1/10 of an inch, so it's not that much at all. The second tool path is a climb pocket tool path to remove the waste down to the exact size of the tenon. As you can see, the bit unnecessarily raises and lowers between passes, and this is an inefficient use of time and travel. Because there wasn't much material to remove, I don't think it was ever the same diameter as the router bit, a faster method would have been to use a profile toolpath set to the outside of the tenon vector with a spiral ramp. This would allow the bit to spiral around the tenon all the way down to its final depth without lifting a single time. That would have been much faster. And the third toolpath is an allowance cut of 0.02 of an inch into the tenon to give the perfect fit to the joint. That's something that has to be calibrated and figured out for your combination of your machine and your bits used. I like to make this its own toolpath rather than including it in the second toolpath because it's just easier for me to not forget about it when working with my machine file template. And again, this cut can be made a little bit faster because it can be done in one single pass because there's just so little material being removed. Here again, I could have saved more time by clamping more to the table at once and loading and unloading the machine while the machine cuts the other pair. To allow the tenons to be longer and therefore have more glue surface area, I made the mortises connect inside the leg. This means the tenons, at the end of the tenons, they need to be cut at a 45-degree angle. Because the cut quality doesn't really matter much, I use the bandsaw for this step. And here you can see how they will join inside the leg. Day one ends with one quick dry assembly, and that lets me know that I removed enough material on the end of the tenons, and the joints are closing all the way that they should. By the end of day one, I was really impressed with how far the build had progressed. All 3 tops were glued up and ready for final shaping. All 12 rails were cut with all of their shaping and details formed. All 12 of the legs were cut and the tapers were formed on 2 sides of each leg. All 24 mortises were cut. All 24 tenons were cut. The joinery was finessed to fit together, and I had all 3 tables sitting in a dry assembly. I thought that was pretty darn good progress for day one, especially considering it was just a regular 8-hour workday. We weren't stressing hardly at all. So with day 2 looking like a really light workload, I decided I wouldn't need Jeremy's help for the rest of this project. Day 2 started with a quick cleanup of the shop, and that's because I like to keep things tidy during the build and not get the shop too messy. And that's because a clean shop, to me, is a much more inviting and a much more encouraging environment to work in. I always use metal tabletop hold-down clips to attach the tabletops to the table bases, and to use them, either a groove or a slot is needed on the inside top of each rail piece. Sometimes I use a biscuit joiner, sometimes I use a table saw, it just depends. In this case, I used the table saw to cut a continuous dado along each rail. The final step before assembly is to add a round over to all the edges of the rails and legs that do not touch the tabletop. Because the slots are so narrow, a typical round over bit with a bearing can't be used for this step. The bearing is too large to fit into the slot, and for situations like this, a specific bearingless bit is used. This can get into a lot tighter places. Finally, the sanding can begin, starting with all of the rails. The narrow faces on all the rails can be sanded at once when held together on the assembly table, and then the wide faces are all done one at a time. Now, a much faster sanding of the wide faces could have been done with my drum sander, but unfortunately, all I had was 80 grit at the time. Also, this is a good example as to why I prefer dog holes on my assembly table. You can hold just about anything, anywhere, in just about any orientation. Because the legs have 2 curved faces, they were best held in place in a vise for sanding, and you can see my spoke shave in the corner of the shot. I found it very fitting to bring attention to it here because I had to use it to clean up a few bits of tear out here and there from the router. That's a good reminder that the CNC machine does not replace woodworking, but rather it complements it. The CNC is just another tool to increase speed, increase efficiency, increase precision, the same way a spoke shave is just another tool to increase speed, increase efficiency, and increase precision over something like a rasp or sandpaper. Due to the multiple dry assemblies and doing a full dry run with clamps, the glue up was uneventful and smooth. That's just the way you want it to be. Everything checked out square with no adjustments needed, which tells me all of the setup work and material holding on the CNC machine was done properly. Time for the tabletops. Now here, I really need to get into the habit of scraping off the glue squeeze out when it's just starting to set up about a half hour after gluing everything together. But in this case, I completely forgot about it and it was fully cured when I got to it. When that happens, I usually like to take a hand plane to shave off the glue bubbles rather than scrape them off. The bond between the glue and the wood is actually stronger than the wood itself, so you're more likely to tear out chunks of the wood when scraping. Right out of the clamps, the panels were 1 inch too wide, which was expected, and cutting the end curve on each of the panels before cutting to final length, it's important in this case. Leaving the extra width in place will allow any tear out from the profile routing to be removed later. To add a little visual interest to the top panels, I wanted to route a wide, sweeping profile under just the curved ends of the tops. I found an old door-making router bit that had a bottom cutter similar in shape to the cloud lifts in the table rails. So in this case, the top cutter needed to be removed and a bunch of spacers were added to make sure that the locking nut remained effective. Because this is such a large diameter router bit, I added the starting pin to the router table, and using this pin to guide the material into the cut will greatly increase control and reduce the chances of nasty kickback. When using a huge router bit like this, a bunch of shallow passes are better than a few aggressive passes or even a single pass. Less tear out, cleaner cuts, and less heat buildup. I really like this detail to the bottom of the tabletops. It's a little detail, but it adds a lot to the overall look of the tables. Now the top panels can be cut to their final width, and it's important to note that the end curves were cut based upon the center of the panel, so that means an even amount of material needs to be removed from each side. This completely removes any router tear out from the prior step. Back to the router table to add a matching roundover on the straight edges, and then back to the sander to prep the panels for finish. That's basically it for day 2. My goal was to get all 3 tables completely built and prepped for finish before my dad arrived so that he could actually help me apply the finish. I expected it to be 2 kind of, extra long working days in the shop, but it ended up being 1 busy 8-hour day and 1 laid back 8-hour day. It's a really good example as to why the popularity of CNC machines in small businesses or even hobby shops has increased so much over the past decade. There's simply no denying the productivity boost that they provide. Day 3 was finishing day. So my dad, both sisters, and 3 nephews, all of which were out of state, they came to visit for a week, and the shop was a huge hit for everybody. It was so cool to see that. These tables were built for my dad, so it was also cool to see him help put the finish on, which was just an oil wax mix. Wipe on, soak in, wipe off. He has a better understanding of the tables now, and he gave us a few rare moments of working on something together in my shop. The last piece of the puzzle is attaching the tops with the tabletop hold-down clips. Center the top on the base, drill a small hole, drive a screw. Super simple. I've used these clips for years. It's just the easiest way, in my opinion, to add a top to a base.